Hey everyone, this is Polynomials video number 10. This one is on something called the remainder theorem. So what is the remainder theorem? Well, it has to do with synthetic division. I'll show you right now. So before I explain it, I'm just going to show you an example of how I can use this and what it is. So just observe for a second. So let's say I got a polynomial like this here. F of x equals x cubed minus 7x minus 6. And let's say I want to figure out the answer when x is 4. So f of 4, right, you plug in 4 to the x's and try and figure it out. Or part B, f of negative 10. How would you figure out, what f of 4, what y is, right, the answer? Well, most of you would probably say calculator. And I would say, that's fine. But what if your batteries died? What if you didn't have it? What if I just wasn't in a good mood and you wouldn't let you use it in class? What could you do? Well, I can do something like this to figure it out. I can actually use synthetic division to solve this. There's actually a trick where I can take the number I plug in, that 4 right there, and just use synthetic division and figure it out. So let's see, I have 1x cubed. Don't forget I have no x squareds, right? I can't skip any powers. So 1, 0, negative 7x, negative 6. I can actually just plug in 4 and figure it out. So let's see. Again, let's review synthetic division. The 1 comes down, then times 4, then 0 plus 4 is 4. 4 times 4 is 16. Negative 7 plus 16 is positive 9. 9 times 4 is 36. And then negative 6 plus 36 is 30. What that means then is f of 4 equals 30. So if x is 4, y is 30. I did that with no calculator, and it's not too hard of math to do. So that's a nice little trick. I can do that again. So up here, with this brown one here, let's say x was negative 10, and I wanted to figure out what y was. Do the same thing. I can put that negative 10 in that top little corner, and I have 1x cubed, 0x squared, negative 7x, and negative 6. So we go ahead and work this out. So 1 comes down, 1 times negative 10 is negative 10, and then 0 and negative 10 makes negative 10. Negative 10 times negative 10 is positive 100. So this makes it positive 93. Gets a little nasty, it's okay. So positive 93 times negative 10 is negative 930, right? Just add a 0. And then add these together, you get negative 936. So, and go ahead, plug this in your calculator and try and figure out what this is. If you did this, that's the answer you would get. I mean, after all, I have x cubed. So what's negative 10 cubed? Well, negative 10 times negative 10 times negative 10, that's negative 1,000. So that's why this gets so, well, I won't say big, it's small, it's negative, but why it gets so large. How about that? So anyways, instead of plug this into my calculator, I can just use synthetic division and just plug in the number I want for x and the remainder. So that last number at the end, that is the same thing as your answer. So here's the definition of it. So if I was you, I would write this down right here. So the remainder theorem just states, let f of x be a polynomial. So, f of x, g of x, whatever, just, have polynomials of some type. F of a is the remainder when you divide f of x by x minus a. So that's the definition I'm giving you. I'll write this down and I'll explain it in a second. So again, f of a, this means that x equals a, right, because I plug in a. So, and a is just some number. It's formal definition, but a could be 5, it could be negative 10, it could be 0, it could be whatever. So when you divide the polynomial, when you divide it by x minus a, that remainder becomes your answer. So you can do that instead of using a calculator or trying to do it by hand. So you can use synthetic division to figure it out. So again, x minus a is a factor. So reviewing division from before, which means that the 0 equals a. So the positive version gets plugged in. It's always the opposite. So let's say, for example, I have a polynomial. I'll make this up. Let's say I have something like this. So f of x equals 6x cubed minus 5x squared plus 4x minus 17. And I want to figure out what y is, or f of x. So if we want to find that when x is 3. So f of 3. If I plug this in with the calculator, I can do that. It's not too hard. But let's say again it broke. Pretend you just can't have it for some reason. And you don't want to do this by hand because it's 3 cubed and 3 squared and all these negatives, and it's just a lot of work to do. It might be easier to use synthetic division as a shortcut. So that 3 goes right here in the top corner, and I can just plug in 6x cubed, negative 5x squared, 4x's, and then negative 17 for the constant number. And I can just use, again, synthetic division and figure it out. So that 6 drops down, 6 times 3 is 18. That becomes 13, add negative 5 and 18. 13 times 3 is 39. Add those together, and you get 43. So then 43 times 3 is 129, because 40 times 3 is 120, 3 times 3 is 9, add them together. And then 129 and negative 17, that makes positive 112. This, of course, in division, is your remainder. So that's your answer. So that's the remainder. That's also the answer. So what that means is that in that polynomial up top, f of 3 equals 112. So you plug in 3 for x, you get back 112 into this polynomial right there. Let's say another one. Let's say I wanted to find f of 0. Well, same thing. I just plug in 0. So, hold on a second. Let's forget that actually. That's too easy. I'm going to go on to one more example and then I'll be done. So I have this one long polynomial to the 7th degree. So g of x, just change the letter, no big deal. 3x to the 7th minus x to the 4th plus 2x cubed minus 5x squared minus 4. And let's say I want to figure out f of, go positive 2. So I want to figure out what y is, or g of x. Wait, not an f. Stupid me. That's g. Keep the letters consistent. I want to figure out what y is, or g of x, when x is 2. So I can put 2 in the top corner and just use synthetic division. So I have 3 x to the 7ths, but I have 0 x to the 6ths and 0 x to the 5ths, right? Don't skip powers. Negative 1x to the 4th, 2x cubed, negative 5x squared, 0x, and negative 4, because again there's no x to the first powers there. So, and now we just go ahead and work with this. So 3 drops down to itself. 3 times 2 is 6. Add 0 and 6. 6 times 2 is 12. Add 0 and 12. 12 times 2 is 24. Negative 1, 24 is 23. 23 times 2 is 46. Plus 2 is 48. 48 times 2 is 96. I'm going too fast here. I'm sorry. You can always pause it and catch up. Negative 5 plus 96 is 91. 91 times 2 is 182. 182 plus 0 is 182. Makes it pretty nice. And finally, I'm running out of room here and I apologize, 182 times 2 is 364. And then plus negative 4 is 360. So it's just a nice different way of finding out what the answer is, what the output is when you plug in 2 into the function. I can use synthetic division and figure it out. So this is my remainder. It's also the answer. And that's it, guys. Thanks for watching. I'll see you in class.